Hi everyone. We'll solve the sixth worksheet today. So it's about inverse function theorem and inverse trigonometric functions, and finally rate problems. So let's start with the first question. So here's a recall first. Inverse function theorem. So we have a function and we want to find the derivative of its inverse. Okay, so suppose f of x equals to y, and to find the derivative of the inverse function, we have this equality. Okay, we will apply this. So here we're given this function f of x, x plus 2 over x. So we will first apply the theorem, then we will find the derivative directly, okay? First we'll apply the theorem, then we'll find the inverse of the function and find its derivative. So what do we do? To find this, we need to first find the derivative of the given function f, then we need to find its inverse, okay? And we'll plug the inverse into the derivative, okay? So what do we do? Here we have the derivative of the given function. So you know the quotient rule, we apply that. So here we have x, so the first one's derivative is 1 times the second one minus the first one times the second one's derivative, which is 1, so over x squared. So we have this. Now this is the derivative of the given function. What do we do now? We find the inverse of the given function, which is this. Okay, you just write, let me write it. So you just write, you just equalize this to y, and then this gives y x equals to x plus 2. So yx minus x equals to 2. Then in the parenthesis of x, we have y minus 1. Okay, so it is this, right? Now what do? We write x instead of y. Okay, so these are just parameters. Okay, don't worry about them. So we have this inverse. Okay, now what do? We write, first we find this. Okay, then we find the whole quotient. So we have f prime, which is this. Okay, let me erase that. Okay, so what do we have there? We have the derivative of the given function here. Okay, we write the inverse into it. Okay, inside function will be the inverse of the given function. So instead of x, we will write 2 over x minus 1. Okay, so here we have. Thus, we get this equality. Okay, these are just some basic operations, so you know it. So we have this. Okay, so for this one, we found minus x minus 1 squared over 2. So what do? We want to find this one, the derivative of the inverse. So we have 1 over this thing. Okay, we have this function. So this is the derivative of the inverse of the function. So now we find it directly. Okay, so what's the derivative? It's this. We know it because we found there. Okay, so what's the derivative of this function? We have just this function, right? X minus 1 to the minus 1. So we find it in derivative, sorry. So we have this function. So they are exactly the same. Okay, so first we apply the theorem, then we found it directly, and we see that, we remark that they are equal to each other. Okay, it should be though, because we have a theorem, it's certain that it's correct. Okay, so here we have this function now, the logarithmic function. First we find the derivative, which is this. Okay, how do we find the derivative of a logarithmic function? We find its inside function's derivative. Okay, write it numerator, then write the inside function in the denominator. So we have this. So what's the inverse? Now, how do we do that? So again, we equalized it. Why? So it gives 5x plus 1 equals to e to the y. Okay. Then we need to isolate x, okay? Then 5x equals to e to the y minus 1. And we divide it by 5, both sides, okay? And we find this. So e to the y minus 1 over 5 is the inverse of this function, okay? And as usual, we write instead of y, we write x, okay? This is the inverse. What do we do? We again find this one. So we write inside of the derivative, we write the inverse of the given function. So we have this, okay? Here instead of x, we will write this whole quotient. So we have this, okay? Now we apply the theorem. Remember, we need to find 1 over this thing. So 1 over 5 over e to the y is e to the y over 5, okay? Don't pay attention about these parameters. It's not that important, okay? So we have this, which is by the theorem, the derivative, sorry, it should be derivative. The derivative of the inverse, okay? This is the derivative of the inverse. Now we find it directly. We know the inverse function is this one, okay? So we find its derivative. How do we do that? So here we have this one's derivative, e to the x times 1 over 5. Okay, it's like a multiple, so we don't care about that. So here we have e to the x over 5. So see, they are exactly the same. This one and this one, they are exactly the same. So again, we found the same inverse, same derivative for inverse, okay? Here we have the second problem, sorry. So we have this function, okay, second's inverse, okay, on this interval. So first we will find the value for this minus 2, okay, then find the derivative. So here we have, we equalize it to y. So if we take both sides, if we apply, if we compose it with second, okay, we will have, this is identity, okay, so we have minus 2 and here second y. So by definition, second y is exactly this, 1 over cosinus y. So we have actually cosinus y equals to minus 1 over 2. Here we have minus 2. So we have this. What should that y be? So it should be pi over 3 plus, why do we do that? So here we have the unit circle, suppose it's a unit circle. So we know that this is pi over 3. When we have here pi over 3, cosinus pi over 3, what's the value of this? So pi over 3 is equal to 60. So we have this triangle. Here we have 60. So 1 square root of 3. And here we have 2, right? So what's cosinus pi over 3? It's 1 over 2, right? But we have here negative. So it is exactly here. Okay. Here cosinus is negative, okay? So what's the angle between this and this one? It's only pi, right? That's why we add it, okay? So here we have this value. So the value of this function at this point is 4 pi over 3. Now what do? We need to find the derivative of the inverse function. So we need to find this one's derivative. We again apply the theorem. We need to have this value, right? F prime f minus 1 of x. So first we need to find the derivative of second, okay, because f is here, second. So what's the derivative of this function? It's tangent x times second x, right? This is the derivative of second x, which is f prime of x, right? So here we have this value. Now we need to apply the, we need to plug this second minus 1, second negative, or second inverse into this derivative. So here we have, okay, we write instead of x, second inverse. So we have this. This is again the identity, so we have only x there. So, and the rest is the same, remaining the same. So remember, if we say second theta is equal to x, then we know this identity, tangent squared equals to second squared minus 1. So if we isolate tangent here, we obtain this. Okay, so second negative is here, we can obtain from there. Second inverse is of x equals to theta. So here we have tangent theta x, okay? And what's tangent theta? From this identity, we obtain its square root of x squared minus 1. So finally, we have this equality. So the derivative of second inverse is this. What about this? Again, to find the value of this function at this point, we equalize it to y. Then we have this identity. By definition, we know it's 1 over sinus. So we have sinus y equals to square root of 3 over 2. And you know that this value is correct when y equals to pi over 3, as we did there before for the previous question, while we were finding the cosinus. Okay, so we have this value. Okay, now what do? We need to find the derivative of this function. How do we find? Again, we write this equality by the theorem, okay, inverse function theorem. So again, while you know the derivative of this function, cosecant, it's minus cotangent times cosecant. So inside, again, we write the inverse of the function, which is cosecant inverse. Okay, so what do we have? We have minus 1 over this thing, because here we have, again, identity. So what's this? For this one, except x, for this denominator, we use this identity again. Okay, you should know these ones. Okay, so we have minus 1 over square root of x squared minus 1 times x. Okay. Okay. Okay, for this problem, we have a square. Okay, and each side of this square is increasing at a rate 6. Okay. We want to find the rate where the area of the square increasing when the area is 16. So as we have a square, each side is of length x, and the area is found by this formula, you know it. So to find the rate, we differentiate this equality with respect to time. Okay, so we have dA over dt time equals to, this one's derivative with respect to t. So it is 2x dx over dt, okay? Here we see x as a function in terms of t, okay? That's why we, again, derivate the function x. So we know the side of the square is increasing at a rate 6, which means the x over dt is equal to 6. And we know the area is 16, so a equals to 16, which gives x equals to 4. X cannot be negative, that's why x should be 4. Now we plug these equalities into this equality, which is denoted by star. So we get this 48, okay, for dA over dt. Now for this one, we have a cylindrical tank. Its radius is 5, okay. It's filled with water, okay. And the rate while it's filling, the rate is 3, okay. So we need to find this, okay, the speed of the height, okay, the rate of the speed actually, while it's filling by water, okay. Now we have this volume V, we denote it by V, so it's computed by this formula, okay. We have a cylinder there, so we have this formula PR squared H, where H is the height, okay, of the water. So we have this. We know the radius is 5, so we have 25 here for r squared. We don't know height, okay, yet. So we know now if we take the derivative with respect to t, we have dv over dt equals to this, okay. So what do we want to find? We want to find dh over dt, okay? How fast is the height of the water increasing? So it means the rate of height with respect to t, okay? So dh over dt here we have dv over dt is 3 because we know it when it's being filled, okay, the rate is 3. So dv over dt is 3, okay? So we just plug these ones into this equality. We have 3 equals to this thing, okay, the right hand side of the equality. So we have dh over dt equals to 3 over 25 pi. Okay, for this question, we have a plane which flies horizontally, okay. So altitude is 1 mile and speed is 500, okay. We want to find the rate, okay. What rate we need to find? We want to find the rate at which the distance from the plane to the station is increasing, okay. So the distance, the rate of the distance when it's 2 miles away from the station. So here we have x for the distance, okay, we denote it by x. We know the altitude is 1 mile, and let this thing be y, okay. So we want to find dx over dt, okay, the rate of the distance. So it's dx over dt. It's 2 miles away from the station, okay, we assume it. So we have x squared equals to y squared plus 1 because this is perpendicular, so we can apply Pythagoras theorem. So we have this. Now what do? We differentiate it with respect to t, with respect to time. So we have this. And we divide both sides by 2. We have this equality, which will be denoted by star. So we have also dy over dt, which is 500, okay, it's given in the question. And we know y equals to 2. It's 2 miles away from station, so it's y equals to 2, we know it. Then what's the value of x? It's by this equality, we find it 5. X squared equals to 5, so it's square root of 5. Again, it cannot be negative because it's distance, okay? So we have this. Now we use this star, okay, to get the x over dt. We know x, we know dy over dt, we know y. So we need to find this dx over dt. We know all other values, so we have this equality, okay. Now we have a street light, okay. It's mounted at the top of a 15-feet tall pole, okay. Here we have, it's 15, okay. And the man is Here we have 6 feet tall, okay, and the speed is 5, okay. First we find this rate. So by similar triangles, we have the 6/15, okay, this is 6/15. You can think it like this. Here we have the angle, okay, so 6, this, and this, 6/15, okay. Then y minus x, which is here, y minus x over y. So we have this equality. Now, by doing some operations, we obtain this 5x equals to 3y. So we differentiate it with respect to t. We have 5 dx over dt equals to 3 dy over dt. So what's dx over dt? It's 5. It's given in the question. Okay. So we have dy over dt equals to this. Okay. We know the x over dt is 5 here, and we have 3. We divide it by 3. So we get this. I guess this is the last question. Here we have a gravel. It's been dumped by with a rate of 30. Okay. Okay. So the pile, we want to find the rate of the height. Okay, of the pile. While the pile is 10 feet high. Okay. So what do we have? We have a volume when it's been filled. We will have a volume, okay, for the gravel. So we have dv over dt equals to 30. Okay, it's given here. So, and we know the volume is found by this formula, 1 over 3 pi r squared h. And here it's given there some. Okay, the base diameter and height are always equal. That's what we want, okay? So base diameter is 2r, okay? This is r, this is radius. Base diameter is 2r. It should be equal to height, which is denoted by h. So we have here h over 2 equals to r. So we also know this. Instead of r, we will write h over 2 and get this. Now we differentiate with respect to t and get this dv over dt, and here we have some constant, again constant, and h3, so its derivative with respect to t is 3h squared dh over dt. Again, here we see h as a function in terms of t. So we know h is 10. We want to find the rate when h is 10, so we plug h equals to 10 and get dh over dt. Okay, the rest we know already. dv over dt was 30, and h is 10, so we have this. Okay, so good luck for the exam, everyone. See you.